Raw data provides no context on its own. Viewed as a continuous scroll of gray numbers, it is indistinguishable from television static. Take a typical ice cream shop ledger. It tracks two specific variables: the daily outside temperature and the volume of kilograms sold. In this table, the figures are listed side by side. If a 30-degree heat wave is forecast for next week, scanning these static rows cannot determine how much inventory is required to meet that demand. Analytical engines like Google Sheets and Microsoft Excel are designed to convert these raw inputs into a functional visual model. Data serves its primary purpose when we use it to define a trend. Its utility is not found in the storage of numbers, but in the application of them. Establishing a baseline begins with the equals average function in Google Sheets. This calculation provides the arithmetic mean of historical sales, giving a starting point for daily volume. Google Sheets is optimized for this initial phase because it allows teams to collaborate in real time, cleaning and formatting the raw entries into a structured set. However, averages have limitations. A mean temperature of 20 degrees doesn't account for the high-demand spikes of a 30-degree day. To understand the actual distribution of sales, we have to look at the data's physical shape. In Microsoft Excel, we can build a histogram. This tool organizes the chaotic entries into specific frequency clusters called bins. Excel uses Scott's standard reference rule to automatically set these bin widths. This mathematical formula ensures the data is grouped in a way that minimizes visual bias. This process replaces the gray list with a colored map of our business. The height of each bar shows exactly how often sales volumes occur relative to the temperature. While a histogram defines the current state of the business, it is a descriptive tool. It summarizes what has happened, but it cannot yet project what will happen next. Predicting future demand requires regression analysis. This is a statistical method for determining the strength of the relationship between our independent and dependent variables. To begin, activate the Data Analysis Toolpack in Excel and select the Regression tool. We first define the Y variable. This is our dependent variable, the ice cream sales volume we want to forecast. Then we set the X variable. This is the independent condition, the temperature, that drives those sales. We must check the Labels box. This ensures the program recognizes our column headers as text rather than including them in the mathematical calculation. Finally, we select an output range for the results and initialize the tool. This converts a general business question into a specific mathematical query. This regression output appears as a dense wall of information. First, we focus on the multiple R correlation coefficient. 0.98 indicates a near-perfect link between heat and sales. Below, the intercept and temperature coefficients provide coordinates for our predictive model. These coefficients translate into a scatter plot where a neon trend line draws itself through the data points. This line represents the mathematical consensus of the entire dataset, providing the projection we need. Returning to the original business problem, the forecast for next week is 30 degrees. By locating 30 degrees on our trend line, we can determine the exact volume of ice cream needed to satisfy the shop's customers. The choice of platform depends on the objective. Google Sheets is ideal for live collaboration and data cleaning, while Microsoft Excel provides the specialized tools required for deep statistical testing. Spreadsheets function best when used as environments for predictive analysis. When we move beyond basic data entry, we can use these platforms to establish the trends that actually drive a business forward.